All right, I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. Again, I thank you for these students. Thank you for your love for us and your mercy to us each and every day. Thank you that you loved us first, and we thank you for your grace and mercy, Lord. Guide our steps today. Help us to glorify you in what we do, Lord. In your name I pray. Amen. Okay, so today we're talking about parabolas. So, let me get straight into it. What is the sort of equation of a parabola look like? So, y equals ax squared plus bx plus c, where a, b, and c are numbers, real numbers, and a is not equals to 0. It's called standard form. Of a quadratic polynomial, right? Well, it's the standard form of a parabola. To be more specific here, if I said that I'm thinking of this as a function, right? If I say this is equal to f of x, right? Then my function is a parabolic, you could say it's a quadratic function, right? A quadratic function is a function whose formula is given by a quadratic polynomial. The graph of these things are parabolas, all right? And, if you want to describe it in terms of classical geometry, I suppose you could do that. It's the set of points which is equidistant from a focal point in a directrix, right? But I don't think we really have much on that in your homework. So I'm going to focus more on just how do we, what characterizes a parabola, right? A few different things. We'd like to figure out, where's the vertex? Does it have x-intercepts? Does it have y-intercept? If we understand those things, then we can graph it, all right? So I'm going to resist the temptation to give you like the general story to start with, and instead I'm going to give you some examples, right? And my examples are going to emphasize the method. So here's my first example. Y equals, let's say x squared minus 6x, all right? Plus 11. There. Let's figure out how to graph this. So what you do is you complete the square. So completing the square gives me x minus 3 quantity squared. Then I have to subtract 9 and add 11. So what I have then is x minus 3 quantity squared plus 2. Right. So let me throw something out here for you. Definition. If you can write f of x, well, not f of x, let's say you can write y equals to a times x minus h quantity squared plus k, then this is a parabola with vertex h comma k. All right. So, and this is called the vertex form of the parabola. All right. So, right here, what I've done, this guy right here, vertex form of parabola. Parabola equation, I suppose, in full sentence here, right? That's the standard form of the parabola equation. Vertex form of the parabola equation. Standard form doesn't really tell me much of anything, honestly. The only thing I can read directly from the standard form of the parabola equation, I can see the y-intercept, and I can tell whether it opens up or down. That's about it. This, on the other hand, if I have my equation written in vertex form, then I can read the vertex straight off the form by means of comparison. So you look at this. This shows me the vertex is where? Negative 3, 2 would be almost right, but it's at 3, 2. Notice the minus. So we have to adjust for that minus. And let's think through this. Why does that make sense? Well, if you plug in 3 into the formula, what happens? That becomes 0, right? So you just get a 2. And if you think about it, that's the smallest value that this formula can possibly take, 2. Right? Because it's usually 2 plus something squared. So it's usually bigger than 2. 2 is the smallest it gets. All right, so then I can use that to graph this thing. So let's see, you're over 3, up 2. So the vertex is here at 3, 2. Can you guys tell me what's another point on this parabola here? 2, 3. Well, maybe not. I don't know. 2, 3. 2, 3 is a. You're right. 2, 3 is another point on there. How'd you find that?
Just 9.
You just plugged it in, didn't you? Right? Just doing what?
I just kind of knew like the first point, so I just kind of did it in relation.
Yeah.
One of the points is 1, 4.
I mean, I think you're right. If you plug 2 into this, you get 2 minus 3, which is minus 1 squared, plus 2 is 3. So you're right, 2, 3 is a point on the graph. Cool. I wasn't expecting that. All right. Very good. But there's a lazier, so let's be lazier. That required actual thinking. What requires less thinking is just to go 11. Aha. That is f of 0, right? F of 0 is 11 here. So if I'm calling this thing f of x, right? Altogether f of x, then f of 0 is 11. In other words, when we plug in x equal to 0, we're up here at 11. The y-intercept is at 11, right? So we got 3 points on the parabola now. Right? And the cool thing about a parabola is if you know where the vertex is, right? How does it behave? It behaves symmetrically about the vertex, right? So like the other half, you can just mirror. Look over here. So roughly speaking, here you go. This is the graph of this here parabola. So here we're looking at y equals to, what was it? X squared minus 6x plus 11, yeah? So if we complete the square, all right, complete the square and then compare to the vertex form, we can read the vertex right off the equation. Let's look at another example. How about y equals to, I don't know, minus x squared plus 4x plus 3 maybe. Let me make that a minus 3. All right, so if I've got something like this, the first thing I want to do is to like factor out that pesky minus. Yeah? So this is minus parentheses x squared minus 4x plus 3, right? So the floor is yours. What do you guys want to do next? Okay, complete the square. Yeah, we can do that. I'll do it, sure. So this is x minus 2 quantity squared, right? Minus 4 plus 3, yeah? So I complete the square. Half of 4 is 2. Subtract 2 squared, which is 4. That, of course, gives me minus parentheses x minus 2 squared. This simplifies to what? Minus 1, right? So now be careful. Be careful with this. The vertex form has a multiplying just the squared term. All right? A does not multiply the k. K is over here on its lonesome. So my current pattern is not quite the right pattern, right? To get the vertex form, I have to go minus parentheses x minus 2 squared. Minus minus gives me plus 1. See that? So the vertex is at apparently 2, comma 1 for this one. Right? That's where the vertex is for this parabola.
Did you just distribute them here?
That's what I did. Minus minus give me plus, but the minus up front stays there. Can you guys tell me something else I could have done here? I mean, this is not prime, right? Example 1, prime. Can't factor without complex numbers, right? Example 2, when we completed the square, we got this minus 1, right? So we could have done this. We could have said, well, this is minus x minus 2 plus 1, x minus 2 minus 1, right? We could have factored it like that. And of course, if you look at this up here, you could have probably just factored it from the get-go, right? X minus 3, x minus 1, see that? This does factor. Yeah? Now, why do we want to factor? I mean, you notice this is the same thing as that, right? This is x minus 1. And this is x minus 3. So just straight factoring or following the algorithm and completing the square using the difference of squares idea. Either way, we're going to come to the same factorization, all right? Why do we like factorization? What does it tell us here? It tells us x-intercepts, exactly. So here, if we've got y equals to minus x minus 3 times x minus 1, this tells me that I have x-intercepts at where? At 3, 0, and also 1, 0. So let's try to graph this thing. So we've got, let's see here, say 1, 2, 3, 4, 1. All right, so let's graph this. All right, so what do I got? And oh, also, one other thing we can add. The y-intercept, that's easy. What's the y-intercept? Right up here, right? This tells me y-intercept is minus 3. When you plug in 0, you get the y-intercept, right? So plug in 0 to any one of those formulas up there, you'll get minus 3, okay? But the easiest one to do is the standard form we started with, yeah? Okay, so minus 3 is the y-intercept. Our x-intercepts were 1, 0, and also 3, 0. And where was my vertex? My vertex was at 2, 1. Man, I like this example. This example is real pretty. All these whole numbers. Fits on the graph all nice and pretty like. Let's make an awesome test question. Let's see here. Don't tell the other sections. That's just my secret between you guys. All right, anyway, so there you go. There it is, the vertex, 2, 1. And there you go. That's the y equals minus x squared plus 4x minus 3. I should mention here, where's the axis of symmetry? Where's the axis of symmetry? It goes straight through the middle of it, right? So if you wanted to picture the axis of symmetry, it looks like this, yeah? So every parabola has an axis of symmetry, cuts it right down the middle, and if you do it right, you can just reflect the parabola from one side to get the other. All right? So how should we find the vertex of a parabola? What do we do? all we got to do is complete the square and compare to the vertex form, right? Now, in the previous section, somebody asked me, is there a way I can find the vertex without completing the square? What do you guys think? There is. In fact, there is, right? Let's work that out. So, if we start, let me call this vertex formula, okay? Let's figure out the vertex formulas. So what we're going to do is we're going to start with y equals to ax squared plus bx plus c, all right? And I'm going to complete the square on that. And from that, we're going to figure out what the formula is for the vertex in terms of a, b, and c, all right? Okay, so first of all, factor out the a. All right, factored a out. Now we can complete the square. So completing the square, we take half of the x coefficient, which is b over 2a in this case. Square that. We have to subtract the square of that, which is b squared over 4a squared. Still got my c over a hanging out over there. All right, so I completed the square. Now what? Now I'm going to clean things up a bit. I'm going to leave the a here. I'm going to write x plus b over 2a there. Square that thing. All right, then I'm going to multiply this a through these two terms. And I'm going to put the c first because it's just prettier that way. So plus c minus b squared divided by 4a. See what I did there was I multiplied the a back through. All right? I just multiplied a back through. Now, there, that's all I got to do. Now, you guys are going to compare this. This is equal to, right? This is equal to a times x minus h quantity squared plus k, right? If you want to equate that to the vertex form, that's what it would look like, right? So if we compare these two formulas, what do you find? What are the formulas? So like compare this to that. What do you see? We find the following theorem. The formula for h is simply minus b over 2a. The formula for k is what? It's this stuff here, yeah? So c minus b squared over 4a. And so there you go. If you want to find the vertex from the coefficients, you can do it. You can double check your work with these, right? You guys have a formula sheet. This was the point in the earlier section where a particular student learned that you were allowed a formula sheet on test 1. He's like, we were? I was like, yes, you were. Oh, that would have helped. Yes, very true. I don't think that's, you guys knew about the formula sheet, right? I'm not like, all right, good. Okay, good. Now, I didn't need these formulas, right? Because I could just do what? I could just complete the square and compare, you know? But you can use these formulas if you want. Like, let's see how they work for example 2. So if, like, for example 2, you know, continued, let's say, let's double check. What would my h be? My h would be equal to, so first of all, what's a, b, and c here? A equals what? Look at the standard form up there, right? So a is -1, b is 4, c is -3 in this case, yeah? So h is -4 divided by 2 times -1, which is 2, right? As we found, the x coordinate of the vertex was 2. What was k in this case? The y component of the y coordinate of the vertex. So c minus 3 minus 16, 4 squared is 16, divided by 4 times -1. What's that give us? That gives us -3 plus 4. minus 3 plus 4, also known as 1, right? So certainly you could put this theorem on your formula sheet and you could use it to find the vertex, right? And there are problems where that would be a smart move. But it is also smart to know how to complete the square to see the vertex, because it is faster. And it does reveal other things as well, right? Because completing the square here also revealed how to factor it. Yeah? Let me look at another example where it's a little bit more opaque. One other thing, though, before I get to that. There is another form of the parabola that we should talk about. What's the other form? How about the x-intercept form? Or let's not say x-intercept form. Nobody calls it that. Yeah, I think you'd usually call it the factored form. All right, factored form. What would that look like? So if you had y equals ax squared plus bx plus c, this is not the factored form, right? That's the standard form. Factored form would look like this. A times x minus r1 times x minus r2. Here, r1 comma 0 and r2 comma 0 are x-intercepts, if this is the case, right? So if you have the factored form, you can read the x-intercepts right off of it, right? What is a formula for the x-intercepts? We already know that, don't we? What's a formula for r1 and r2? The what? Plug in 0 for y. Yeah, set it equal to 0. And what is that? What is the formula for that then? If we put this equal to 0, rather if we put the ax squared plus bx plus c equal to 0, we know that. That's the quadratic equation. Its solution is given by the quadratic formula, right? So r1 and r2 are exactly the things that you get from minus b plus or minus the square root of b squared minus 4ac, yeah, divided by 2a. So we know that r1 and r2 are given from this formula, right? And what else can we derive from this? But there's fine print here, right? What's the fine print? Provided what? If I'm going to say those are x-intercepts, those r1 and r2, those had better be real numbers, right? How can I be sure that r1 and r2 here are real numbers? I need to be given that b squared minus 4ac is greater than or equal to 0, right? I need that the discriminant, the thing inside the square root, is non-negative. If it's negative, it's a complex solution, and so I really shouldn't call them x-intercepts, should I? The algebra still works. You can factor it, like I have written here, but it's just it doesn't have the geometric interpretation of being x-intercepts. There's more we can do, though. More I can say here before I go on to more examples. And let me get this general formula stuff out of my system here while I'm on this roll. What's r1 plus r2? What happens when you add this formula? Let me not even write it out. Just think about it in your head. What happens when you add the plus solution and the minus solution? Think about it. The square root piece gets a plus and a minus, but it's the same thing. So those cancel. So all you're left with is minus b over 2a plus minus b over 2a. What's that? But these have the same. So they survive. You get minus b over a, right? So then divide this by 2. What do we find? We find r1 plus r2 divided by 2 is equal to minus b over 2a. What is minus b over 2a? See right there? It's h. It's the x-coordinate for the vertex. So this is h. So this gives us yet another beautiful result for the parabola, which says that the vertex is where? Is at the average of the roots. It's at the average of the roots. That's even true when the roots are complex. So if the roots are complex, the vertex is at the real, it's at the real part of the solution. But this is a general truth. If you want to find where the vertex is, look at halfway between the x-intercepts if you got them. Like here, x-intercepts were what? 1 and 3, yeah? See that? Where was the vertex? What's halfway between 1 and 3? It's 2, yeah? Look, so there is a web of interconnected truths here. Every one of them that you understand, you get a little bit stronger, a little bit harder for me to make you, for me to trap you in some question, right? Like the more you understand, the better chance you have at answering all the questions I ask you like the next test, right? Because these ideas are all intertwined, right? The factoring, the completing the square, the meaning of the vertex, the meaning of the x-intercepts, all of these things work together. Let's look at one that meaningfully involves completing the square in such a way that it's kind of ugly. Yeah. What example was I on? 3? Is that right? I think I was in example 3. How about this? We want to graph y equals to, oh, I don't know, x squared. All right, minus 8x plus 1. That's yeah, I like this one. I'll tell you what, let me not make it plus 1. Let me make it plus, let me think about this here. Let me make it minus, oh, I don't know. I'm thinking. Minus 10. There we go. Okay, so I want to graph this thing, right? First of all, you can try, I mean, of course, if you can find the x-intercepts, that's lovely, whatever. But I think here it's going to be a little bit ugly. See, because if we complete the square, x minus 4 squared, yeah, minus 16. See, because I take half of 8, which is 4. I square it, that gives me 16. I subtract the 16. The minus 10 is still there, yeah? And so what I have, right, is x minus 4 quantity squared minus 26. Oof. All right, this graph's kind of big. What can I do? Well, I mean, it is what it is. So where's my vertex? Four comma minus 26. That's where my vertex is at. How about my x-intercepts? Does it have x-intercepts? The answer is yes. If you complete the square, and when you do that, you get minus a number, that means that you can repackage it as difference of squares, and you can factor it over the real numbers. It's not pretty, but you can do it. So this I look at as x minus 4 squared minus the square root of 26 squared. All right? I again go back to, I think of this as a squared minus b squared. I remember that a squared minus b squared can be written as a plus b times a minus b. Remember I told you guys that day 1? I said we'd use it. I meant it. Like every day. Like most days. Anyway, so this is my a squared. That's my b squared. So I get x minus 4 plus b plus the square root of 26. X minus 4 minus the square root of 26. Aha, now we have put the quadratic into factored form, right? What is the point in that? Well, from this I can read the x-intercepts. What are the x-intercepts? So this gives me x-intercept what?
4 plus square root of 26.
Yeah, 4 minus the square root of 26 for that one. And this one gives me 4 plus the square root of 26. Now, what is the square root of 26? It is very close to the square root of 25, right? What's the square root of 25? 5, right? So this is, you know, square root of 26 is, it's about 5.1-ish, yeah, roughly speaking. So this is approximately 9.1, okay? And this is approximately, you know what, 4 minus 5.1, so like minus 1.1, right? something like that. So now that I know those, I can make a pretty decent graph, right? What's the y-intercept? Minus 10. Okay, so let's do it. All right, so I need, let's see here. I need, oh, I got to get all the way to minus 26. I better make this by 10. So well, still too much. Man, I need a bigger board. Actually, what I need to do is put my x-axis a little bit higher, yeah? So everything interesting, like most interesting things are happening below the x-axis, so I should just scooch the x-axis there. So I got myself a minus 10, minus 20, minus 30 down here, okay. All right, great. And let's see here, I'm doing interesting stuff. I think this, I can just kind of go ching, 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 ching. Well, I tried. I don't know. Again, if we had graph paper, it would be lovely. So I have what? X-intercept at minus 1, 1, minus 1.1, so it's about here, right? I have another x-intercept over here at over here at 9, right? And where's the vertex? It's at 4, right? So it should be halfway between those. So the vertex is like right here, right? So this is, I mean, to be fussy, this is 4 minus the square root of 26 over there. Over here you've got 4 plus the square root of 26, right? And in the middle, you've got 4. And the vertex is where? At minus 26, right? So it's down here. And you guys told me the y-intercept, what was it? Negative 10, so that gives me another point right here. If the y-intercept is at minus 10, by symmetry, what's another point on the graph that we can get? So this is what? This is like 4 units over, right? So to go 4 more units, we should get another point over here, like this, right? So by symmetry, there should also be the point, you know, like 8, comma minus 10, I believe. So like 4 to go from here to here, and then another 4 to flip over to there. By symmetry, that point 8 minus 10 should be there. All right? And I mean, you can check me on it. If you plug 8 into this formula, do you get minus 10? What happens if you plug 8 into the original formula? You get 64 minus 64 minus 10, which is minus 10. So indeed, this point is on the graph. And so, now we can graph. And you just have to keep in mind the general shape of a parabola and just do your best. I mean, you do your best. And this is the best I can do since I haven't chose my scaling very quite rightly. But anyway, there you go. That's the graph of this here parabola. How else could you have found the x-intercepts if you're just still not completing the square? If you have devoted yourself to not understanding completing the square for the remainder of the semester, suppose you're such a person, you have chosen, this is something I can never conquer. I've decided to be stubborn and refuse to learn it. If you're such a person, that would be me when I took this course, all right? Because I'm an idiot when I was taking this course. Not that you're an idiot, I was an idiot. There doesn't have to be a symmetry there, right? Just because I'm saying I was an idiot for doing something that you're also doing doesn't mean that I'm saying that you're an idiot for doing the same thing that I was doing and was being an idiot. Although I think me not calling you an idiot in that regard, it's starting to get kind of thin. You're not idiots, though. I don't want to say that. Anyway, my point to you is please learn completing the square. It's not that big a deal. Learn it. It will help you. And it will make half of what I'm saying less like bizarre. And I know that about half of you don't know it. Or half of you, I think, are solid on it. Another 30% of you are fuzzy on it. And another 20% are just nowhere close. All right, so there's varying degrees. But It's not a big deal. You just take, half of that, square it, subtract the square. Right? If you're still not getting it, come to my office hours. I will spend 20 minutes with just you alone doing completing square after completing square after completing square until it finally sits in, okay? Like, I can do that for you. It's fine. All right, so my point to you then is just this, that we could also have found the x-intercepts using what? If just setting aside my previous rant on completing the square, you could use the quadratic formula, right? The quadratic formula will tell you where the x-intercepts are, right? And by the way, something else I should mention, you can work backwards from the quadratic formula. Yeah, I have intentionally not told you this before, but it is true. If you can find the solutions to the quadratic equation, you can work backwards and factor, right? You realize that, yeah? Okay, let me get off my soapbox here and work another example for you. So here's one. How about this? Y equals to 3 times x plus 1 times x minus 7. Find the vertex. I have freed us of the problem of graphing this one. We don't even need to graph it. Let's just use what we have to find the vertex. How are you going to do it? Find the vertex. Distribute the 3. Yeah, we could do that. All right. We'll come back to that. The x-intercepts? Okay, yeah, let's go down that path. So what are the x-intercepts? R1 is what? R1 is -1. R2 is 7, right? So what's the average of the roots? It's what? It's -1 plus 7 over 2, which is 3. What is 3? 3 is the h, right? It's the x-coordinate of the vertex. So aha, h equals to 3. So that's part of the story, but we want to find the vertex, right? So we also need to find the what? The k, as I call it, right? How do we find k?
Could you just plug in 3 for the x?
Ah, yes, very good. So if we think of this thing as f of x, right? Then k should be equal to f of h. That's something I don't think I've said yet today, but it's kind of common sense. Since it's a point on the graph, x and y have to be related by the formula, right? So that means when I plug in h into the formula, I must get out k, because h comma k is the vertex. It's a point on the graph. So how does that work here? So that's f of 3, which is 3 times 3 plus 1 times 3 minus 7, which is what? 3 times 4 times -4? Yowzers. That is minus 48? Wow. Okay, so vertex is where? 3 comma minus 48. Now, you wanted to do it a different way, right? And I think what you wanted to do, and this is also a legitimate way to do it, was to multiply this out, right? So the other way to do this would be 3, multiply this out, I get what? X squared plus x minus 7x, so that's minus 6x minus 7, right? Then multiply through, we get 3x squared minus 18x minus 21, right? Now if you do that, you gain other insights along the way, right? Like, what's the y-intercept? Now I can tell you, it's minus 21, right? But if I do this, then we could go, aha, so a equals to 3, b equals to minus 18, and c equals to minus 21, right? And then we could go back to our h and k formulas and figure out the vertex that way, right? So like h minus minus a minus 18 divided by, 2 times 3, also known as 18 over 6, also known as what? 3. That's good. And k is c minus, well, let me put the numbers in. I'm using that formula right there, okay? So c is minus 21 rather, minus b squared. Oh, 18. I got to square minus 18. It's kind of big. I left my calculator at home today, so I'm in trouble. 4 times 3. I guess I could, I'm relatively certain that number works out to 27. I'm just kind of working backwards from my other answer. So the way that, if you think about 18, I can get rid of, fine, I don't have a calculator, so 18 times 18 over 4 times 3, I can look at that as 6 times 3 times 6 times 3 over 2 times 3, which is cancel the 3's and cancel the 2 and the 6 to give me another 3, and then this one and that to give me another 3, and I get 3 times 3 times 3, which is 27. Okay, great. Anyway, the point is, you do the arithmetic, you get minus 48 here. All right? My point to you is that if you understand what I've told you, there's more than one way to do it. Yeah? Which way is better, the purple way or the blue and the red way? The answer is yes. Either way is fine, as long as you understand what you're doing and you have a clear path towards your goal, right? Your goal is to find the vertex. It's not apparent. Now, what's yet another way we could have done this? We could have completed the square, right? If we completed the square, that would have also found the vertex for us, yeah? Any questions? Let's see here. I may not be to your class yet. I'm trying to go through the My Labs. I had clicked something where it had final submission a week after it was due, and I don't want that. I want you to be able to keep working on it afterwards, but for a late penalty, if for whatever reason you don't have it all done after a week, you should still be able to work on it for 10% or something deducted. Hopefully I have changed it so you can do that now for all of the assignments. I don't think I got to your section yet. What do you guys, section 3? So I did 1 and I think I did 2. I'm not to 3 yet, but I'm planning to do that. So, and my fear, I've been told, this is the source of, I don't know, I'm still trying to figure out what's making Canvas tell some of you guys graded, your assignment's already been graded, and then you can't get back into the assignments. It's not an isolated incident. There's been 5 of you, at least, in different, well, not of you guys, but generally speaking, across all my sections, I have a smattering of students who Canvas tells you that the homework's graded and they won't let you back in. When that happens, I've been told that if you go to the modules and you click on the homework through inside the module link, it'll go back in. If you just try to do it through My Labs, it won't work, is what I've heard.
Yeah, so I've been going back to the module.
Good, yeah. Which is insane, right? It shouldn't matter which way you're going.
I have another question now.
Sure, go for it.
Normally, how it shows it does a pop-up.
Uh-huh.
The screen's a lot bigger. So when I try to do it, it always comes up as this little small square, and I can barely even see anything on it.
Oh, yeah, I don't know how to fix that kind of thing at all. Do anybody know what he's talking about? He says, do you have a workaround?
Yeah, that happens to me if I go into the homework through Canvas, but if you go into the Pearson site, it does full screen.
Okay. So the key is to go. So the key is to go in through Pearson, except in the case that it says that your homework's been graded and you can't go into the Pearson.
Every time I do it, because I do my homework in sections, so if I do 5 problems, within 5 minutes, somebody will tell me okay, it's been submitted, and it'll tell me 12 out of 40. It lets me go back in afterwards, and I see. So it's not a problem for me.
Cool. Let's see here. I've forgotten another part of the story here. Let's do it. So y equals to minus 2x squared minus 4x minus 2. This one won't take long. So factor a minus 2 out. What you got? And so one of the things I should emphasize in this lecture is there are three cases, right? There are three cases. Either the discriminant is positive, it's 0, or it's negative, right? If it's negative, it's like example 1. That means that the polynomial is prime, which means there are no x-intercepts, right? Its vertex is either above or below the x-axis, and it either opens up or opens down in such a way that the graph never crosses the x-axis, right? If the discriminant is positive, though, then you get distinct real roots R1 and R2, and the graph crosses the x-axis at R1 and R2, right? The other possibility, though, that we haven't hit today, but now I'll do it right now, is this. And what happens here when you complete the square? See this? Completing the square is factoring, because that is x plus 1 squared. So so what does this mean? This means that the vertex and the x-intercepts are one and the same in this case. So the vertex, and now you have to think about this like an elephant with wings. Every elephant has wings, right? They're just set to what? 0, right? So if you compare this to the vertex form of the parabola, which I have now erased, so compare this to, a times x minus h squared plus k, right? You can see that the vertex is where? It's at -1, 0, right? But that is also what? That is also the x-intercept in this case, yeah? And so this is an important example because this is one of the big parts of the story. Like next week, we like to talk about the possibility that the graph can bounce off the x-axis, and that's what happened here. What's the y-intercept? -2, right? So roughly here. And so vertex point, by symmetry, we can bounce like that. There you go. So this is the case that the discriminant 0, we get one that bounces off the x-axis. Yes? Oh, here, I can fix that. Kind of. I tried. Okay, so yeah. Thank you. That was a very helpful comment. I much prefer that comment to be made before I hit the record button. Muchas gracias.